rocket science for dummies, and more, and I'll explain that. If the whole rocket science is like the Empire State Building, then rocket science for dummies means that this video will take you from ground floor up to the third floor maybe. But unfortunately, I'll have to start from the basement to address the claim that says rockets can't work in space. So, where did that claim come from? It came from misunderstanding of Newton's law of motion and the belief that rocket engines needs to push against something to move the craft, same as the helicopter rotor or a kayak pedal relying on the medium, which for rockets in space would be vacuum. So at that point, the most common example to show that this belief is wrong is the man on roller skates or wheelchair throwing a bowling ball to one direction, and the reaction is him going in the opposite direction. But obviously that still doesn't tick with conspiracy theorists. They'd say the bowling ball pushed against the air. So I'll take it a step further. How about using a balloon with the same size? If the concept is pushing against the air, then the effect should be the same, or even more, since we can push the balloon faster than the bowling ball. But that still doesn't happen. A similar and more practical example is water rockets. They're simply plastic bottles filled up to 1/3 of water and 2/3 of compressed air. If the concept is pushing against the atmosphere, then what's the need for water? And the video shows a comparison for the same water rocket with water in it and with air only. And check this video, it's really educating and it's a big channel. I'll put a link in the description. So I think now we're finished with the basement and we're at ground level or level 1, appreciating the rocket engine's capability. Look at the footage from Apollo 11 launch and tell me, what did you notice? Oops, you missed it, so I'll play it again. I think you missed it again. Well, it's only 1 second, so you gotta look closely. Yes, so what we're seeing here is through that 1 second, the engine consumed 20,000 kilograms of fuel and ejected them as 20,000 kilograms of gases at a speed of 2,500 meters per second. That's Mach 7. And we can rephrase what we just said in a more simple way. The engines ejected 20 kilograms of matter at a speed of 2,500 meters per second, and that happens every second. So I think this gives you an idea of how powerful these engines are and what they are meant to do. So level 2, engine thrust and rocket's velocity. As I said in the previous level, the engines ejects 20,000 kilograms at 2,500 meters per second every second. So as you see the equation in the bottom left side, 20,000 kilograms per second multiply 20,500 meters per second. So if we took all the units or the notation to the right side this way, you can see here that we have kilogram mass and meter per second, that's acceleration. Mass times acceleration, that is force, and the force is 50 million newtons. So now we have the downward force, which will also have an upward reaction of the same force. So we can calculate the acceleration of the rocket. 50 million newtons divide the rocket mass, that would be the acceleration upward. Not exactly, but I'll explain it. But let's put the numbers. So 50 million divide 2 million point or 2.8 millions, that 17.85 meters per second square. That's the amount of the acceleration that the engines are capable of. But that will not happen because you have a downward acceleration of the Earth's gravity of 9.8. So this is what you have to do. The actual acceleration would be 17.85 minus 9.8. The result would be 8.05 meter per second square. But that's only for the first second. For the following second, we'll do the same equation, but you'll have to reduce the 20 tons that you consumed in the first second or for the previous second. And as you see here, we have higher acceleration, a little bit higher, but not that much higher. As the rocket consumes its fuel, uh, this acceleration is increased. So these are all simple things. You can calculate the altitude that the rocket can reach. You can calculate the velocity at any specific time or specific moment. But it's just, I'm just giving the basics. You cannot really do that. You can do it in a perfect environment, but not in reality, because there's a lot of factors like the air drag and like having to reduce the pressure in order to avoid dynamic pressure on the craft, or when the fuel tanks are almost empty, you have a very high G that could crush your craft. So now I think we can go to level 3. Atmospheric pressure and rocket engines performance. This is very simple. What you see here on the left, this is a rocket engine, and that bulk on the top is the what's called the combustion chamber. This is where the chemical reaction takes place and produces a lot of pressure, and that pressure pushes the gas outside of the nozzle. But we shouldn't forget that there's one of atmospheric pressure uh, outside the nozzle, or outside the throttle, or the gas or the combustion chamber. So the combustion chamber have the capability of producing, say, X amount of atmospheric pressure, and that X amount doesn't change. It depends on the amount of fuel you are injecting into the chamber. So if we have the same amount of X atmospheric pressure, but outside of the nozzle we have very, very little atmospheric pressure, like almost zero, then we gained a more differential pressure between the inside and the outside, and that will result in higher velocity of the gases. And as we shown, it's all about the velocity of the gas exiting the nozzle and how much gas or how much mass of that gas you can expel every second. So that concludes the 3 levels that I talked about. I could talk about more later if someone like why the nozzle looks like this, and is there a specific shape for nozzle in the stage near the ground or in space. There's a lot of things that we can discuss. But now let's recap. 1. Rocket engines can work in space. 2. Rocket engines work better in space. And 3. Rocket science is not so intimidating if you look deeper into the basics and start analyzing them. I really didn't read much books about rockets and rocket science. I just the usual roaming on the internet and using some of the basics that I know in physics. So I hope you enjoyed it, and thank you for watching.